Welcome, everyone, to our first community forum this week. I'm Kirby Kester, President-elect of the Hawaii Crop Improvement Association, and we're here to have a friendly and respectful talk story about farming, food, and our future. We will discuss the real challenges facing farmers on Kauai, how food is grown today is grown and raised safely and responsibly, and what tools are used to preserve and protect our lands and resources for future generations. Our panelists are respected farmers and scientists from Hawaii and the mainland will be able to answer your questions about agriculture, GMOs, pesticide use, and farming on Kauai. Before we begin, though, I would like to invite Auntie Nani Hill to start off our forum with a pule.
Oh, it's pretty tall here. Before I start the prayer, I just want to say that when Susan called me, I had to think a little bit, and I felt that this is right for me to do because my pico, my belly button, is literally planted deeply in the roots here on the west side of Kauai, meaning that I was born in Hanapepe, and when I was born, a part of my belly button, my pico, was planted in the ground. And I've grown up here, which goes all the way from Hanapepe, and my ancestors, the Makea family, at one time lived in the village in Miloli'i. So they walked this land. And so I feel so passionate about the land and the people. And so this is why I come forth to do this prayer. E pili kako. Let us pray. Ka ho'okumu a malama ana I ke akua. I mua o ko alo loa a ke ola mauloa. Creating and sustaining God. In your presence there is life. Living water springs up, and the lehua blossom blooms where you pass. We drink in your creation of our beautiful island with our eyes. How strong, upright, and graceful Kauai stands. Seeking the life that comes from you, we are gathered to kuka kuka, to talk about the sustaining the life of our aina, our land. This aina that feeds us. May we, all of us, come forth in wisdom and compassion, honoring each other as good neighbors, he alo a he alo, face to face, with respect, knowing that we can agree to disagree, that we can speak in harmony as well as in discord, that our minds can apprehend alike as well as differences, that our resolutions and deliberations can be common as well as distinctive. But what matters at the close of our presentation and discussion is that the intentions of our hearts and our minds and our souls are common with the motto of our beloved land, Ua mau ke ia o ke aina o ikapono. The life of the land is perpetuated in righteousness. Hele mai ke akua, usher in thy presence into this place. Amen.
All right, thank you, Auntie Nani, for that great pule to start off our event. I would now like to introduce our two lovely moderators for the evening, Lori Ho and Susan Ta Kaneko. Lori Ho, this one, is a graduate of Kamehameha Schools and obtained a degree from the University of Hawaii at Manoa in agriculture technology. She's worked for the United States Department of Agriculture with the Natural Resources Conservation Service for 32 years, with 25 years of that here on Kauai. She believes in building effective partnerships with government agencies, community groups, and individuals having good working relationships with everyone. And Susan Tai Kaneko has over 15 years' experience in business and economic development. She was most recently the director for the Kauai Economic Development Plan at the Kauai Economic Development Board, overseeing initiatives in renewable energy, food and agriculture, and strategic planning. She also manages the implementation of the county's 10-year comprehensive economic development strategic plan, or better known as SEDS. Prior to that, she was director of the SBDC, working with small businesses in our local community. They will facilitate discussion with the following panelists: Jerry Arnellis, president of the Kauai County Farm Bureau; Dr. Dennis Gonzalez, former director, Pacific Basin Agricultural Research Center; Dr. Kevin Folta, University of Florida Horticultural Sciences; Dr. Stephen Savage, Savage and Associates; and myself, Kirby Kester. So with that, I'll now turn over the mics to Lori and Susan.
Gosh, yeah, he is tall. Mahalo, Kirby. Aloha, mahalo for everyone joining us this evening. Before we start, really, in order to have an informational and productive event tonight, we wanted to go over a few house rules for discussion and for Q&A later. Lori, do you mind grabbing this one? So what we'd like to do is encourage everyone to participate actively, practice active listening, listen for understanding, and please no side conversations to distract away from our presenters and the discussion at hand. If you do need to have side conversations, please feel free to step outside, take care of business, come right back in. Please respect each other, the topics and the time frames tonight. You hear it in Reverend Hill, in Auntie Nani's remarks. You know, we want to share respect and aloha for each other. So please show respect, and please keep an open mind. When you're receiving constructive feedback or when you're giving constructive feedback, please do stay open to the things that are being shared tonight. Also, please communicate clearly and concisely. Enable everyone to be heard too. So when you'll see we go through the Q&A later, the question and answer, we'll ask for everybody who has a question, please go ahead and ask your questions. And if you have a second question, if you wouldn't mind, please allow others to ask their questions, just to have at least one chance. Seek understanding of differing viewpoints. As Auntie Nani said, we have to agree to disagree. And despite whatever anyone says, please keep it respectful, and then please just consider what each other has to say, because we truly believe as the moderators, everybody deserves to be heard. But please agree to disagree. Keep your sense of humor. We don't need anything to be tense here. This is purely just to share information and ask questions, to have any of your concerns and your inquiries addressed. And for a couple housekeeping items, if you don't mind, if you haven't already, please turn down, silence your cell phones or turn them off. And anyone needs to take a potty break, if you head out, the men's restroom is to your left and the women's is to the right. And I'm going to hand it over to Lori to introduce our first speaker.
All right, thank you, Susan. Now, for our first presenter, Kirby is the current president of the Hawaii Crop Improvement Association and is employed by BASF Plant Science in Kekaha as the Applied Genetics Manager. With 18 years of broad experience in the seed industry on Kauai, he now manages seed production for the development of new traits in corn, rice, soybeans, sunflower, and canola crops. So, Kirby. You're up.
I feel like all I'm doing is moving this microphone up and down. Thanks, Lori. As previously stated, as she said, I've been working in the seed industry on Kauai for the past 18 years in various roles entailing field supervision, production, administration, And now I do trade development and some regulatory compliance work for BSF. I've been a member of the Hawaii Crop Improvement Association since 1995, and am currently the president-elect. So, no problem, and a board member. So HCIA, in case you don't know, is a trade association of the seed companies in Hawaii. And the seed industry on Kauai is made up of four companies: Dow AgriSciences, DuPont Pioneer, Syngenta, and BSF. Collectively, we farm about 13,000 acres of land on Kauai, spread from Polihale to Hanamalu. This number represents less than 20% of the 80,000 total tillable acres of farmland on Kauai. We employ roughly 600 employees annually, depending on the season of the year. Most of them reside on the west side of Kauai. We annually contribute roughly $80 million to the Kauai economy. We do not have any income in Kauai via sales, nor are we government subsidized, so this money is a direct injection into the economy in the form of salaries, contracts with local businesses, construction work, and other money spent in our local communities. Nearly 100 businesses or associations work with this industry. So why is the seed industry on Kauai? The simple reason is the weather and the ability to carry out our plant breeding and seed production work year-round. Most people don't realize that nearly all plants have the ability to be improved via plant breeding techniques. There are tremendous efforts around the world on all the major food crops to enhance things like yield, quality, and resistance to various pests and diseases via plant breeding. Our industry started on Kauai in the late 1960s, mainly just to increase parent lines of corn during the winter months for commercial production and sales in the U.S. Corn Belt. In plant breeding, since there's typically visual plant selections conducted on each cycle, where you're looking for the best characteristics, it can take numerous generations, sometimes up to 15, to create a new product. So if these activities were only conducted in the U.S. Corn Belt, it would take up to 15 years. And since Kauai's climate is conducive year-round, we complete 3, sometimes maybe 4 cycles in a year, which in turn really helps us reduce the product development timeline. Our fundamental business is to produce seeds sold to farmers in the U.S. and around the world. They may be created with both traditional breeding techniques as well as the latest biotechnologies like genetic engineering. We develop plants with improved characteristics based on the demand of our customers, who are farmers that want crops with higher yields, better disease and insect resistance, with better nitrogen use efficiency and drought tolerance. The ultimate goal of our breeding efforts is to create plants that provide the highest yield and nutritional values or industrial use while utilizing the smallest environmental footprint possible. That's why biotechnology is very important as one of the tools in providing food for the future. Thank you.
Mahalo, Kirby. Before I introduce the next speaker, just as an FYI, earlier this evening, a sheet of paper, the program with the agenda and other information on it was handed out earlier. If you came in a little later and you didn't get a copy, if I can find out who has extra copies, is that Chris? It's Chris. You can see Chris over here if you need a copy, or you can raise your hand and she'll bring a copy for you. Also, Chris, was there a registration form or other handouts that you'd like people to? Okay, in the front, whenever you get a chance, if you can sign in if you'd like. And then there will be some other useful informational handouts outside too, if you'd like to pick it up on your way out. Our next presenter is Dr. Dennis Gonzalez. Dr. Gonzalez was born and raised on a sugar plantation in Kohala. He recently retired as a director of the USDA Pacific Basin Agricultural Research Center in Hilo. As a director, a post that he held actually for 10 years. He led the team that developed the virus-resistant transgenic rainbow papaya that saved the papaya industry in Hawaii in 1998. For this work, he and his team received the Alexander von Humboldt Award in 2002 for the most significant accomplishment in American agriculture in the past 5 years. I'd like to introduce Dr. Gonzalez. And can we pull up Dr. Gonzalez's PowerPoint? Thank you.
Thanks for having me, and yeah, I can see that.
You can see.
Yeah,
Okay.
and I'm very happy to be here. Actually, I actually started my career in Kauai way back in 1965. I just graduated from the University of Hawaii, and I took a job as a technician at the University of Hawaii Experiment Station behind Sleeping Giant, and essentially, my experience on Kauai motivated me to be a scientist. And we still have roots to Kauai because my son Andrew is actually married to a gal from Hanapepe. Her name is Rochelle Jim. Now, I'm going to go fast because I have about 5-6 minutes to give this talk. But essentially, I want to just give you a skeleton of our work on the transgenic papaya, and I hope you folks will have questions later on. But there are several important points that I'd like you to remember. If you look at the title, essentially the work that we did on the transgenic papaya was done by public sector scientists like us. I was at Cornell, people at the University of Hawaii, and USDA. And our goal really was to help the papaya farmers in Hawaii. And it's a long story. I actually started working on trying to develop a control measure for papaya way back in 1978. So it took a long time. But basically, what I want to talk to you about is the biotechnology aspect of the papaya story. Next slide. Now, why are we working on this? Because, you know, like a lot of stuff, a papaya is severely affected by a virus. The papaya ring spot virus is worldwide, transmitted by aphids, and it's been in the Hawaii since 1945. So it's not a new virus disease to Hawaii. But you can see the damage it causes. Next slide. Now, actually, I just gone to Cornell, and I came back to Hawaii for vacation, and the dean asked me, Dennis, the virus is in Hilo, and in Puna, we have 95% of the industry. What happened if the virus goes from Hilo to Puna? Because at that time, Puna had no virus. And I said, as a plant pathologist, I said, oh, you get wiped out. So he said, well, Dennis, can you try to develop a control method? So we actually started the research way back in 1978. Next slide. Now, getting to how we developed the virus-resistant transgenic papaya. Basically, you can sort of think of it as vaccination. We took a small piece of the virus, and using all molecular techniques, we inserted it into the genome of the papaya, or the chromosome. And the concept way back in 1985 was that we could theoretically vaccinate a papaya and make it resistant to papaya ring spot. This was a new concept, but essentially you can, if you think of it as vaccination using a very small part of the pathogen, essentially the papaya ring spot virus. On the left, there's the blue part is a small gene, and then we put it into the chromosome on the right. Next slide. Well, you know, from 1984 to 85, we started the research, and lo and behold, 6 years later at Cornell, this picture was taken. On the right, on the left was a genetically engineered papaya with a cold protein. When we inoculated it with the virus, it kept on growing, whereas the one on the right was sick. So we thought, oh my gosh, you know, our idea of vaccinating a papaya to be resistant was true. Now, this was in a greenhouse. Next slide. Now, you remember in 1978, I came to Hawaii, and the dean said, try to do something, because the virus might go from Hilo to Puna. Hit the next slide. Well, in May 1992, the long-awaited invasion of the papaya ring spot virus into Puna was detected. So a potential now became a reality. Next slide. Now, this is how Puna papaya was being grown. Beautiful. It was a way of life in Puna. The virus comes in, detected in May 1992. By 1994, next slide, complete devastation. The industry is just being devastated because the virus is spread by aphids. There's no resistance, and this is how the industry looked like in 1994. Next slide. Well, because in 1991, we had this small plant that I showed you, Richard Manzard of the University of Hawaii started working to bring the resistant plant to a commercial type. And indeed, by 1995, we had developed the sunup and a now famous rainbow papaya. And you can see it over here. So in order to see if it would work, in 1995, when the industry is in trouble, we do a field test in Puna. And then the scientists like us now, we're public sector scientists, start to deregulate the papaya. Next slide. And then you can see in 1996, the field trial. On the left is the infected papaya, non-transgenic. On the right, you can see the papaya is growing well. This is the rainbow papaya, resistant under field conditions. Next slide. And you can see the middle part is a solid block of rainbow papaya in Puna, growing nicely. All the papaya around it are the non-genetically engineered papaya just being infected. On the left, you can see the rainbow papaya. On the right were the kind of papaya that were being infected. That's why they call it the papaya ring spot virus, had all these symptoms. Next slide. Now, from 1996 to 1998, as public sector scientists, I had never done this before, but in order to help the farmers, we felt we had to fill out the applications to get it deregulated with APHIS, EPA, and FDA, and the licenses. To get licenses, we had to get license from Monsanto, other companies. Essentially, we worked with the papaya industry, and they got the licenses. We turned over the seeds to the papaya industry in May 1998. Essentially, seed distributions were made to the farmers. And later development in 2003, the papaya was deregulated in Canada, and in 2011, the papaya was deregulated in Japan. Next slide. Now, this is what happens. Now you can see why they adopted it. On the right side, you see non-transgenic papaya in Puna, all infected. In the middle part, the green part, that's a transgenic rainbow papaya growing very nicely. And then, so that's how we reclaim the industry in Puna. Next slide. And then now if you go to Puna, more or less you'll see this. More or less you'll see healthy papaya. Next slide. Now, the virus is still around. That's what I like to stress. Don't make the mistake that the virus is gone. It's still around. You can see a case in 2004. A grower planted a rainbow papaya in the background and planted a non-transgenic apo in the foreground, and you can see the big difference. So the virus is still still around in nature. Next slide. And this is my last slide. You know, what I want to stress is that the work that us public sector scientists did was really to try to help the farmers, and as a result, I think you see that the papaya is readily available to consumers, and today about 85% of Hawaii's papaya is genetically engineered. Thank you very much.
Mahalo, Dr. Dennis. Our next presenter is Dr. Kevin Folta. He has been recognized as an award-winning scientist studying the genomics of horticultural crops and the molecular biology of signal transduction in plants. Hope you're going to explain this, right? He has authored over 50 scholarly reviews, research articles, and book chapters, and served as an editor to 2 seminal texts in fruit genomics. Dr. Kevin Folta.
Thank you very much. It's really a pleasure to be here, and I'm very grateful for the opportunity, especially how many scientists get to go up on stage after one of their heroes, and that's really great. Thank you. one of the things that's come up a couple times here today is the phrase, we have to agree to disagree. And I believe that if we're talking about a restaurant, a movie, maybe my haircut, we can have different opinions. But on science, I really want to agree. It's too important for us all not to just pursue the truth. What do we need to agree to agree. As a scientist and a teacher, if we disagree, it means I'm not trying hard enough to give you the evidence that I formulate my point on, and that I'm not understanding yours. So together, this is a back and forth. It's a sharing of evidence that ultimately, at the end of the day, we need to agree. And that's where I'm coming from here. I wanted to talk about a little bit about what science says about transgenic technology and about what we refer to as GMO. I'll give you a quick discussion of a couple key points, and I'll show you some things that we need to think about when we go through these conversations and we listen to multiple sides of this discussion. Next slide, please. So this slide reminds us that nothing we eat is natural. When we say natural, we like to think something that's been untouched by humans, something that's there in a state in which it occurred naturally. When humans showed up, this was there. Nothing is that way. Every bit of food you eat, with some very rare exceptions, have all been genetically manipulated by human beings through the process of breeding and selection. So we've gone through this very blind process of marrying plants that may have never been able to do this on their own in the process of crop improvement. And some of our best crops that we have are hybrids between things that could have never possibly have hybridized without human intervention. Okay, next slide, please. And these are just some pictures of the before and afters of some things that we're familiar with, whether it's tomatoes, corn, or bananas, that what existed in nature and what existed after human intervention are two very different things. And the point of this all is that we've been stewards of the development of these products. And the reason we have such a wide variety of produce, fresh fruits and vegetables that are available to us year-round, just about year-round in most places, is because humans have been very active in this process of breeding and selection. Really what I always refer to as genetic modification, which really is what we're doing. We're changing the genes, this time by breeding. And so this is why I never really liked the term GMO, because everything that we're eating is a genetically modified organism. We're mixing genes in a way that nature never intended, just by breeding and selection. Next slide, please. So some of the questions that I would like to at least introduce today and hopefully kind of stoke your mind towards the Q&A session later on is why do we need genetic engineering? And a lot of this goes back to the idea that scientists that are performing breeding and selection, just making crosses and then selecting the best progeny with the desired traits and using those in the next generation to incorporate more traits into a very elite line, it takes time. And there's no such thing as a free lunch. You have a very good, highly improved plant that has 99% of the traits you want, but is missing resistance to a given disease. But you got another plant with horrible horticultural traits, but it's got that disease resistance. To breed that back in may take years, especially if you're dealing with something like apple trees, might take a lifetime. To be able to take that single gene for disease resistance and move it over here accelerates what the breeding process does. Only we're able to do it maybe in a year, 2 years, 5 years, rather than over 5 years, 10 years, or a lifetime. And that's the magic of being able to use the genetic modification technology or transgenic technology. What is regulation like? And there's a lot of information out there that says this is a highly unregulated rubber stamp technology that anybody can release anything they want without any trials, when actually the opposite is true. This is a technology that goes through so much scrutiny at every level through the process, and the deregulation process with multiple agencies is not fast and it's not cheap. And it isn't that they all go to EPA, FDA, and USDA all at one time. They go to one, they get approved or not approved, go to the next, and go to the next. If I have a plant, like I have one in my refrigerator, that strawberry that can grow in the absence of fungicides, if I wanted to try to release this, which we won't because we can't, it would take 10 years and probably $10 million. And my laboratory and university don't have that kind of money or time. And an industry could use it. So instead, they put more fungicides into the environment. How do you know it's safe? And this is always a tricky question for a scientist because a scientist can't tell you anything is safe. Safe is too much of a solid word for a scientist to use. You know, we don't pretend to know everything, and we always have to leave the door open a crack to maybe learn something new. But what we can tell you about this technology is that there is zero evidence of harm. When we look at the effects on humans and animals that have been tested, or animals that have been tested, and then the use of this product in 90% of acreage and 70% of consumer products, we don't see any hard evidence that there can be tied directly to these products. And this is really important because this would have shown up either in the company's trials, which some people don't trust, and that's fine, but there is a very strong element of companies need to protect themselves and make sure that a product before it goes out is really good in this litigious society. The tests that normally go on at the deregulation level are very stringent. The tests that go on in laboratories like mine as independent scientists, if I found something that was wrong, I would report it and I would publish it in the best journal ever. And then I'd come back and get my Nobel Prize. Because there are many eyes that are continually scrutinizing this kind of material. The other level that this gives us some sense of the lack of harm in these products is looking at epidemiological data. If we look at data compiled by analyzing populations, you never see any specific tie to consumption of genetically modified products. And why is it relevant to Kauai? It's relevant to Kauai because of the intensive breeding that goes on here, the traditional breeding and development of inbred lines and hybrids. So whether it's corn, canola, whatever is being bred here, these frequently harbor traits that allow them to be used without insecticides, so the BT trait, or the Roundup resistant trait, glyphosate resistant trait. So these traits are usually present in these lines and are bred for other elite traits to make these superior products. They're relevant to Kauai because these products do require less herbicide or less insecticide, less pesticide. And that's a key point of the discussion here tonight, that when a plant is making a small protein that can inhibit the feeding from certain moths or butterflies, that it doesn't require treatment from beyond. It produces the protein that limits the feeding. Next slide, please. So what about all the problems we hear about? And I just have a couple slides here, and the last ones I'd like to show you reflect some of the concerns that people have and some of the best evidence that people use against this technology. And many of you have seen the pictures from the next slide. So many of you have seen this one. The lumpy rats from the Seralini paper last year in September. And this is a shocking image that's used on signs, it's used on anti-GM literature, it's used if you Google GMO and cancer, this comes up in images over and over again. This is the shock value that they want you to see. As a scientist, I analyzed this picture, and surprised someone else didn't. They have the rat that was fed GMO allegedly, one that was fed GMO with Roundup herbicide, the other one with Roundup herbicide alone. What's missing? The control. How about the rat that just ate regular rat chow? Well, if you go to the next slide and we look at table 2, turns out he got cancer too. So here's an example where the authors, the leading authors, biotechnology critics, leave out critical pieces of data to make their shock value increase. That's not science. And that's really an unfortunate use of the scientific literature and of scientific media to push an agenda. And personally, I think that's really deplorable. I have a major problem with that. Next slide, please. So I just want to give you some quick thoughts, and I'd really be excited to take your questions. If we don't get a hold of your questions today, please feel free to email me or contact me. I'm here to help you. I'm an independent scientist. I have no ties to any companies. I'm so happy to share the information. The technology was tested. It has been shown to have no evidence of harm long before it was released. It's been used freely in the public now for 16 years without any incident. The technology does have strengths and limitations. Nobody's going to tell you that this is perfect technology, and it's always improving. And looking forward, I certainly believe that this will be part of our agricultural approaches. I and many other scientists who work in very integrated departments with everything from organic and sustainable culture all the way through plant physiology to biochemistry to space biology, we see that transgenic technology is a perfect match for other types of low-input agriculture. That if you could find plants that would tolerate the environments and be able to grow with less agricultural input, whether it's fertilizer, insecticide, whatever, and be able to identify conditions that would maybe provide a cultural system, a production system that would allow them to thrive. You could take something like organic and transgenic and marry these technologies to make something that would really be best for the environment, for the consumer, and for the farmer. With that, I'll stop and we'll answer questions later. Thank you very much.
Mahalo, Dr. Folta. Up next, we have another renowned agriculture scientist who will shed some light on the pesticide issue. Dr. Steve Savage has more than 30 years of experience in agricultural technology, having worked in academics at Colorado State University, at a global research company at DuPont, at a biotechnology startup, Mycogen, and for the last 16 years as a consultant. In recent years, he's worked extensively on the topic of sustainability. I'd like to bring up Dr. Steve Savage.
Thank you. Always glad to be in Kauai. The first time I was coming here, it was 2 days before we were going to come, and Aniki hit. So I'm glad that this time I didn't have the same effect on Kauai. Okay. I think pesticides are a difficult issue because unlike biotechnology, there were bad old days when it comes to chemicals. And you only have to go back to when I was 7 years old and the book Silent Spring was published. That was 51 years ago. And it was published because there was a need for this. There was a real problem with what was going on, and there were severe problems. And by 1970, the EPA was established, and it began a process that I've been able to watch a great deal of dramatic change in what are pesticides. So I'm very glad that we're not using the pesticides of the 1950s or even 1960s, just as I'm glad we're still not driving in the kind of cars that I drove in back then. Okay, but what I'd like to do today is there has been an issue raised about what are called restricted use pesticides, and there's public data available about their use on Kauai. And what I want to do is tap into a bunch of other very public, very transparent data resources that are available to everybody that can help put that into perspective. Because I'm afraid most of the people I meet still have about a 1960s image of what pesticides are, and that isn't where we're at. Okay, next slide. And so that's the background. And these are the data sources that I'm going to be talking about. And to save time, I won't go through that list. And truly, I'd be happy to help anybody figure out how to negotiate some of these. Some are very easy to do. Some of them are a little more challenging. The last one there is 2 million rows of data per year. Okay, next. So the first thing that you can do is by looking at the product labels and the MSDSs, or the material safety data sheets, which are available online, and these are all things that have to be EPA approved. You can find out what this list of chemicals that, the idea of a list of restricted use pesticides, that sounds pretty scary. But the key thing to do is, first of all, to find out, well, what are they? And to understand how much is being used, you need to understand some of these are 3% active ingredient granules, some of these are 7 pounds per gallon emulsion concentrates. So you digest through that data, and what we see is that in terms of actual chemical, actual active ingredient, we're talking about something on the order of 29,000 pounds per year in Kauai. Now, 29,000 pounds sounds like a lot, but let's put that in perspective. First of all, a bunch of that happens to be used in the coffee plantation. And actually what's being used there is a very logical herbicide that allows them to control weeds without having to disturb the soil around the coffee plants. It's a very good approach, okay? So that's 14% of that use. Another 9% of it is essentially for fumigating grain storage bins. I'm sure you've all seen houses being tented for termites. This is the same process, but you do it in a grain bin to keep rats and mice and insects from damaging the grain in the bin. So that's another 9% of the use. The rest of it is what is actually used on the field, and most of this, in this particular case, is used on corn. And that's all part of the public data. And when you look at the fact that there's something on the order of 12 or 13,000 acres, as Kirby said, of these crops planted here, and you take those pounds, and now we're down to 1.9 pounds per acre per year, okay? And if you calculate what that means per square foot per year, this is for the entire year, it's 0.00004 pounds per acre. We're not talking about huge quantities. Next slide. Okay. Now, the other thing is, when you hear restricted use pesticide, I think the assumption is, oh, well, we must be talking about toxic pesticides. There are such things as acutely toxic pesticides, but that's really not what this particular list is about. Actually, only 2% of the total pounds of stuff that's being used in this setting is actually any more toxic than the caffeine in an energy drink or a cup of coffee in the morning. Caffeine is actually a pesticide that coffee makes. It tries to keep away insects with that caffeine. We just happen to like some of the other effects of it. Okay. Now, another 16% is in that range where it's gram per gram. It's less toxic than caffeine, but it's a little more toxic than ibuprofen and Advil. That would be where that herbicide that is very useful in the coffee would be. And also, some of that is also used in the corn. Good point about this, that's a key herbicide in being able to farm something like corn without tilling the soil. That's how you can have a cover crop in the off season and then be able to get rid of the cover crop and come right in and plant your corn. That's a key chemical for that. This is a big part of dust control. Okay, beyond that, another 10% of it is, it's sort of, another 42% of it is somewhere between hydrogen peroxide that you might gargle with and ibuprofen, okay? And then 13% less toxic than hydrogen peroxide, and then 30% of it is actually less toxic than the citric acid in an orange. So you're thinking, well, why aren't these pesticides toxic? It's because they're used, most of them, the greatest part of the use of these is actually for the control of weeds. And the things that are able to control weeds are generally not toxic to mammals. And in the particular case of most of these, that's what we're talking about. So the next slide. And that use rate, is that a lot? The USDA does surveys every few years across areas like the Corn Belt, and they're able to say, well, how much are the farmers in North Carolina or Kansas or Iowa using? And so I looked through that data set and pulled the data that, again, matches up with the same chemicals we're talking about being used in Kauai. And all the blue bars are the 3 years of data for all of these different parts of the Corn Belt. And the red bar on top is if you assume that the Kauai use is actually 2 seasons a year. It's probably more than 2 seasons. But conservatively, what's being used on corn in Kauai is kind of a lot like what's being used in all the rest of the corn acres in the United States, but actually a little bit to the low side. So we're not talking about high rates. The next slide. In California, I'm from California, and we're a state that we have what we call mandatory use reporting. So any commercial application of a pesticide, whether it's to agriculture or landscape or buildings and things like that, that all has to be reported to the California EPA. And there's a big database, and it's really pretty easy to access. And so you can say, gee, I want to know what were the chemicals used on arugula last year, or you can say, what were these pesticides that were used in Kauai, what were they used for in California? So I pulled the data from the most recent year available, which is 2011, okay? And it turns out that in that year, from this list of chemicals we're talking about, we in California used 2.8 million pounds of those, and we used it on more than 150 crops, again, from arugula to almonds to collard greens to peaches, you name it. And in fact, here are some of the biggest uses, a lot in the tree nuts, a lot in forages, animal feeds, pastures, alfalfa, basically things to feed animals, but a tremendous amount in vegetables, cotton, citrus, grapes, other fruit, row crops. We use a lot of these same pesticides. And in California, we're pretty proud of the fact that we probably have some of the most stringent state-level EPA type of activity. Our regulation of pesticides at the state level is pretty intense and more intense than most states. There are a lot of things that can be used in other states that we don't allow in California. And it's very important because we grow so many different crops in California. So anyway, what's being used here in Kauai is not something extraordinary or unusual. This is something that's widely used. Next slide. So just to make a summary of this, first of all, I just say pesticides may not be what you imagine that they are, and their use in agriculture is a really, really highly regulated activity. And this has been the case for a long time, and it continues. Things come up, new issues are raised, the EPA brings in expert panels. It's an ongoing process, but one that people should feel very confident about. Everybody who commercially applies these things has to have training, and what restricted use means is that only the people that have the highest degree of that training are allowed to use it. The main reason that that's what is required for these things we're talking about in Kauai is that you need to use them with certain restrictions so that you don't get them into water. Because even though these things may not be toxic to mammals, if you put them right in the water or get them there easily, you can have effects sometimes on invertebrates, sometimes on fish. It's something that can be avoided if people know what they're doing and they understand how the distances that are needed and the characteristics of soil, all that kind of thing. That's all possible to do. That's what the training's about. The last point, I won't get into the details here, but every year the USDA goes out, samples thousands of samples of food and water from all around the country in commercial channels. They take these to several labs around the country, test each of them for usually more than 300 different pesticides to see what's there, and then they report the data. It's sort of like farmers in America get a group project grade based on a random sample from some of those farmers. It would be a pretty scary thing if you were in college and that's what your grade was going to be based on. But basically every year the farming community gets an A, and it's really pretty impressive. And again, I can show you this data. That's the 2 million rows. There are summaries that you can look at. Okay. And I guess that's the final point. When we hear something like, oh, pesticides are being used, the question needs to be asked is, well, which ones, how, that sort of thing. It's not a straightforward, oh, this is automatically scary. And the reason that pesticides are being used is because pests are real. And we have some very nice stories where there's a nice transgenic solution and whatnot, but there are a lot of pests, and it's something that has to be dealt with. Organic farmers have to use pesticides. Pests are real, and there's no getting around that. So anyway, I'll stop there. Thank you.
Thank you, Dr. Savage. Finally, we would like to introduce Jerry Ornelas, a Kauai native and farmer, retired as a research technician from the University of Hawaii's College of Tropical Agriculture and Human Resources in 2011. Ornelas started working on his family dairy farm in the 1960s, then continued on with vegetable and orchard crop farming. Today, he grows tropical fruit trees in Kapa'a homesteads. He is the president of the Kauai County Farm Bureau and chair of the Kauai County Agricultural Advisory Committee. Jerry is the Kauai representative to the State Board of Agriculture. He previously served as the vice president of the Hawaii Farm Bureau Federation. Jerry?
Thank you, Laurie. Aloha ahi ahi. Good evening. Welcome to our guests from off island. As you've heard on my bio, I've lived on Kauai all of my life, primarily on the east side. And I guess the question being, what are we doing here tonight? Yeah. One of the reasons we're here tonight, I think, is that as farmers, we have not done a very good job of interacting with the public. Today, our community on Kauai is deeply divided, and I can understand why. For somebody that is uninitiated in the use of pesticides, and I happen to hold a Category 10 applicator's license, it is scary. It is very scary. For somebody who does not understand genetic engineering, it is very scary. There are a lot of unanswered questions, simply because people have never asked the questions. Today, they are asking those questions. And that's why we're here. I'm not gonna give a formal presentation because I really want to get to the questions, but before I left home, my daughter said, "Dad, keep an open mind, but not so open that your brains fall out." So I'm gonna try and do that tonight. But just a few things I would like to say. Farmers make up 2% of the population nationwide, and less than that in Hawaii. So here you've got, and many of you are in this room today, you've got 2% of the people feeding 98% of the population. Yeah. We can never raise the kind of numbers when it comes to demonstrations or even public meetings. Yeah. And that's what we're faced with today. So our task is really to foster deep dialogue, deep inquiry, and find out why are we so deeply divided on these issues. And I have my own thoughts on it. When I was born in 1949, there were 2.7 million people on Earth. Today, there are 7.5 billion people. This is just in my short lifetime. In 2050, there will be 9.5 billion people on Earth. If you think that we can feed that population with pre-industrial agriculture, I can tell you right now, that will not happen. There is no way that that can happen. Why should I be concerned about that? I have a 15-acre farm in Kapa'a Estates. I do all right selling my longans, lychee when I have it. Why should I be concerned? We should all be concerned. We're all in this together. I've been told, what are you worried about? All we have to do is feed this island. That is not a compassionate way. So the other reason I'm here is that I really want to hear what is on your minds. And judging by the kind of questions you ask, yeah, that's the takeaway for me. That's where the learning experience for me is tonight. So with that, I'll turn it back over to Laurie.
All right. Thank you very much, Jerry. It is time. It is time for questions and answers.